So hello everyone. Today I am going to solve this problem called shortest path, in which we have given a string and we have to tell the minimum time in which we can pick all the balls color R, G and B, and we have to pick at least one ball. So it is a very basic problem. In this, actually, the main concept, the main thing, the concept which applies to the question is of sliding window. And in this we have to find, so the question breakdown as we have to find a minimum size of sliding window which contain both R, G and B. For example, giving checking for the input one, we have to check R, G and B. So what is the size of minimum to check to solve R, G, B and G? So here this is, and in this not possible, so we written -1. For example, taking this problem, so 7, and we have to RGB, say R, so RGB this size, so I'll put it 2. And so we have to means we have to return one digit, we have to subtract from the final answer. In this question we will RGB GGG R, this will be, so the size of the shading window is 6, so we have to return 5 because we have to return 1 minus on the small index. So let me show you how to code. Firstly, we will initialize int vector will begin, and int and integer for the also 0, and we will declare an ordered map. And I am going to declare this because to check whether how many elements are present in the current sliding window. And int p, and firstly, and means we our sliding window is pointing from, means in this condition our sliding window is pointing from 0 to 0, means it contains only one element which is 0. For an example, I am going to, means if I am writing a, means if there is a string RRR and is 0, so it only contains first element. If and if begin is 1, element is 1 and end is 2, so it will contain R and smaller, which is it because this R is first index and this R is second index, so it will contain these two indexes. If the our begin is 2 and end is 4 by chance, let's take example, so it will be what is it will be second index and it will be 4 index, so it will contain 3R. So I am just explaining this code, nothing else. So here, and firstly, so we have we are making begin and both with 0 index. So firstly we have to initialize, mm, and now we have to run this while loop till we n is less than and or equals to s dot size. So if firstly we will check whether the sliding window contains all the characters or not. So and we are going to make an integer m equals to int underscore max, because it will store the maximum value of the sliding window. Is this will be our answer, it will store our answer, means, so if p dot size equals to 3, then our m equals to max of m comma begin and minus begin and minus begin, means if our size of the our p, means our the map is 3, then it will it will be such that then it will contain all the characters, so it can be a possible answer. And we have to check for the minimum answer. Sorry, I'm writing answer. And it can be a possible answer, and we'll just check for find for the minimum possible answer. So I'm going to write this. And uh, and we will check whether if p of p dot count of s of begin is equals and now. So if the element is present, we will move our begin pointer to left and erase the variable which was pointed by the begin variable from the map. So here I'm checking for the condition. If is equal to 1, then we have to erase it from the map. Yes, erase equal begin. And if it's not that, then we have to just decrement this s of begin, and we will check for minus minus, and here we will use begin, increase our begin pointer. And so if this condition fails, if p equals not, then what we have to do, we have to just push the element, and we have to increase the end pointer and put that p of end pointer in this, in the map. It will put it. And if end pointer is less than h dot side, because there will be because to handle the edge case, when because in our condition we write that when end pointer is less than h dot size. So it will be when it is less than h dot side, it can be a case when end is just less than h dot size, means end is equal to last index of the array, which is equal to h dot size minus 1. Then it then when it comes to this condition, it will increment our end variable. And then and at that condition, if we will try to add this element to our map, then it will give a error, because it will the string within we will say out of bounds, that means it will give a runtime error. So we have to check for the edge, we have to place the element to check for the edge case. So in my opinion, our code is correct. And we have to check for one more condition, whether if m is equal to int max. If m is still equal to int max, then it means there is no possible answer. So in case of no possible answer, what we have to return, just we check it, we have to return -1. So we will return -1. No, sorry, return -1. And here we have to return m. And so let me hope to extend this code. So it is the wrong answer by that. What? Let me check it. 2 minutes just. Actually, the problem is, and why we have to check whether count will be always equal to 1. We have to check the value stored at the index. Sorry, that's the biggest problem I have. That is the problem I have doing. Whether check for this condition. Now our test cases are passing. So that's the main thing. We have to check, we have to find the minimum sliding window which contains both the letters. So what we have done, let me explain this again. We have begin and ending, just find the values and then making an order map. And then we have put the first index, because our both index are pointing towards 0, and so 0 element should be present already. So I have done this code. So this, if p size is equal to 3, then if size is equal to 3, then we will store the minimum index. And if the value stored at p or begin is equals to 1, then we erase the s of begin, else we will simply decrement. And if the size is not equal to, then we will increase end pointer. And if end is less than its size, because there will be a condition in which because we have placed the end is while end is less than h dot size. So here will be one condition when end is equal to h dot size, end is just less than h dot size, and it is end just less than size, means it is at the last, it is a pointer pointed by the last value stored at means last index, and